in order to figure out the area, you really need to know something about the function. You need to be able to evaluate it. So that's what we've done. We've evaluated it here at n plus 1 points, enumerated 0 through n. And those are the numbers out of which we're going to get all of our approximations to the integral. So somehow we want to average these numbers. So here's our goal. Our goal is to average or add. I'm using average very loosely here, but I'm going to say add up these numbers to get an approximation to average or add the y's to get an approximation to the integral, which we know is the area under the curve. So here's what the Riemann sum is. It's the following thing. You take y0 plus y1 plus up to yn minus 1, and you multiply by delta x. That's it. Now this one is the one with left endpoints. So the left-hand sum. There's also a right one, which is if you start at the right-hand ends, and that will go from y1 to yn. Okay, so this one is the right hand. Right Riemann sum. All right, those are the two that we did before. Now I'm going to describe to you the next two. They have a similar pattern to them. And the one with trapezoids requires a picture. Here's a shape, and here's a bunch of values. And we're trying to estimate the size of these chunks. And now, instead of doing something stupid, which is to draw horizontal lines in rectangles, we're going to do something slightly more clever, which is to draw straight lines that are diagonal. You see that many of them actually coincide pretty closely with what I drew there, although if they're curved, they miss by a little bit. All right, so this is called the trapezoidal rule, because if you pick one of these shapes, say this is y2 and this is y3, if you pick one of these shapes, this height here is y2, and this height is y3, and this base is delta x, this is a trapezoid. All right? So this being a trapezoid, I can figure out its area. And what do I get? I get the base times the average height. If you think about it, if you work out what happens when you do something with a straight line on top like that, you'll get this average. All right, so this is the average height of the trapezoid. And now I want to add up. I want to add them all up to get my formula for the trapezoidal rule. So what do? I have delta x times the first one, which is y0 plus y1 over 2. That's the first trapezoid. The next one is y1 plus y2 over 2. And this keeps on going. And at the end, I have yn minus 2 plus yn minus 1 over 2. And then last of all, I have yn minus 1 plus yn over 2. All right, that's a very long formula here. We're going to simplify it quite a bit in just a second. What's this equal to? Well, notice that I get y0 over 2 to start out with. And now y1 got mentioned twice each time with a factor of 1/2. So we get a whole y1 in here. And the same thing is going to be true of all the middle terms. You're going to get y2 and all the way up to yn minus 1. But then the last one is unmatched. Yn is only half, only counts half. So here is what's known as the trapezoidal rule. Now, I'd like to compare it for you to the Riemann sums, which are sitting just to the left here. Here's the left one, and here's the right one. If you take the average of the left and the right, that is a half of this plus a half of that, there's an overlap. The y1 through yn things are listed in both, but the y0 only gets counted a half, and the yn only gets counted a half. So what this is the symmetric compromise between the two Riemann sums. This is actually equal to the left Riemann sum plus the right Riemann sum divided by 2. It's the average of them. Now this would be great, and it does look like it's closer, but actually it's not as impressive as it looks. If you actually do it in practice, it's not very efficient. Although it's way better than a Riemann sum, it's still not good enough.